can you do me a favor? Can you tell me what it would cost to machine parts? He says, well, I'll tell you what. The first thing I do, I get a master drawing, I double the price. First thing I do. I open it up, and if I see tolerances that don't make sense, I double it again. If you got any G, D, and T symbols on, I double it again. He said, that's the truth. That's what happens. This is a nonlinear chart. So if you had plus or minus 5 with a 16 or an 8 finish, that's your price. This chart has been used all throughout NASA to try to make things on budget, on time. Clearly, President Reagan liked to, well, Nancy Reagan says that he ran his administration through an astrologist, right? I mean, and when you think about what we do at NASA, we do the same thing. Because that star today, that's a planet, and it's all about the alignment of the planets. It's about schedule. Not so much cost at JPL at NASA, it's about schedule. Making parts on time so that we can meet that critical launch date to make that schedule. And this has helped us get there. I have a class in 2 weeks at the Kennedy Space Center. I just came back from Johnson. Like I said, I've been doing this for about 4 or 5 years. It's the highest rated class in all of NASA. I enjoy being able to just help somebody make a part, like I did Ken. I scared him a little bit. But the bottom line is you can make and fix anything, as my daughter says, except a broken heart. And have that faith and that comfort level and go about and make those parts. Thank you.
So, Richard, do you have any questions that you might have?
Hours.
About curiosity?
But these guys know how to make parts.
John's got one back there.
Yes, Mr. SpaceX.
So I've got an interesting question here. What's your opinion on match drilling?
Yeah. What's your opinion on match drilling?
Yes.
Take it to curiosity. So we have the sky crane and we have the rover. They're actually bolted together using a whole bunch of sep nuts, separation nuts, explosive nuts. And to drill Curiosity, you need the master jig. To drill the rover, you need the master jig. Clearly a case where 70s and 60s technology has been replaced with high-end CNC. High-end, what I mean, high-end, high-accuracy CNCs that can put holes in within a half a thousandths. CMMs that can check to 1 or 2 ten-thousandths of an inch. These were clearance holes, by the way. A sep nut goes together, separation nut, a titanium conical washer and a stainless steel female conical washer goes together with a 30-second gap all the way around the surface. But the mindset of a lot of aerospace companies, they're afraid of this. By the way, it was your part that failed. You refused to use that master jig. You broke the rules. I'm okay for match drilling when it's needed for interchangeability. You want to swap out a Merlin engine and put another one in? I'm okay with that. So the mounts to that, match drilling using a master jig, I think that's a great idea. The question you have to ask yourself is, why do you need match drilling? Now, if you're making an airplane wing and you pre-drill your skin and not your spars, great place for match drilling because sheet metal is meant to move. You can't pre-drill sheet metal and normally have it line up to any levels of accuracy. Match drilling sheet metal, absolutely. Match drilling plates of steel, you better have a good reason why you want to do it because it's very seldom needed today with current technology. Remember, Eli Whitney was using a file. Today we have computers and CNCs to do that. Yes?
Do you guys run 5-axis machines at JPL?
We run 8-axis machines, 9-axis machines.
On a mill?
Go ahead, call me full of shit.
The wire EDMs already confuse me with the extra
Yeah,
axis.
and we have one of the few EDMs with a rotation. So we have X, Y, U, V, and a rotation. So we have a very large boring mill. All right, so X, Y, Z, A, B, C. There's 6. and I have 3 Z's. So I have a Z, a W, and a U, or V. So I have a rotary table that moves in and out, as well as a spindle and a column. And I can use 2 of the 3 at the same time. So it's an 8-axis machine, I can use 7 axes. All right, a couple of them with Z's, but we posted. Now, if you have a multi-axis lathe with a main and a sub-spindle, again, you got 5, and you may have 4 typically, so you have 9, although they're C1, C2, etc. We have multi-or live tooling lathes where the first part is being machined, and then it hands it off to the second side of the machine. It grabs it as you machine another one. So, but I left JPL, and I had a friend call me up and said, Richard, can you help us out with some 5-axis programming? I didn't realize how few 5-axis programmers are out there. I came out of a different mold. I realized that as a kid. I think the Angels might have broke the mold first. I'm not 100% sure. But I can sit in front of a computer and learn Gibbs Mastercam in usually a few hours. I taught myself SolidWorks. So I went to work for a company for a couple of weeks during the summer making clavicle plates to reconstruct broken motorcycle riders. I have 2 busted shoulders. It was nice to be part of the manufacturing of rebuilding motorcycle riders. But I enjoy 5-axis programming, but there are so few of them out there. And a lot of them will do 3-axis programming, bring their parts into Word, and cut and paste with 5 or 6 offsets, 7 or 8 offsets. I'm not real big on capital punishment, but I'm okay with shooting a football. I'm sorry. Yeah. Now, so we made some parts for the treadmill, for the ISS. And true and sad story. It's up there right now. No, it's not actually. Actually, it's going up, right? So we made the parts, and very complex parts. Now, I had two sides of this wonderful equation. I got to make parts, and I got to bitch about the parts during a DFM class. And every once in a while, I get the designer in my class. This was the case. And we had the part up on the board. Yeah, Stephanie, it's my part. Why? He says, nobody has told me how to bolt parts together. I don't understand a bolted joint. What I do understand is that SolidWorks, well actually this I was Pro E. It's very easy to put together a very complex cartoon or model and not worry about the machinist trying to make it. I don't have to worry about it. Because if it works in solid model, and if it's and she looked at it, she looked at it for manufacturability, no strange angles, no U drills going in, no S drills. I just don't worry about it. And it was sad to see that a lot of designers don't understand a bolted joint. They also don't understand that you should allow clearance for a bolted joint. And if it doesn't need to move, put a dowel pin hole in one of the parts, the accessible part, and finish drilling that dowel pin so it goes together. Just about everything on Curiosity unbolts in a matter of a few seconds. Everything's doweled. We do that for planetary protection. So we build it from a mechanical standpoint, we disassemble it, we wash it, we bake it for microbes, we double seal it, bring it back, and then we have them reassembled in the clean room with dowel pins. But bolted joints evidently are difficult to design, leading to many, many complex 5-axis parts at NASA. Good. Yeah. That damn treadmill.
I understand.
The treadmill that's actually up and running had, I want to say bags of rags. I'm trying to remember the NASA term. What? Socks. Yeah, because it bounces up against the wall. The new one will hopefully eliminate the bags of socks. What's that? Socks were cheap, and it worked. Yeah, just a bad design, but yeah, we're coming. By the way, I don't know how layperson gets into it, but I know as an ex-JPL or ex-NASA employee that the ISS is screaming, begging for projects. They don't have enough projects. They are looking, just begging for people to come up with something because we don't have a shuttle anymore, and they really want to keep the ISS not only up there, but busy. They want science projects, and we get asked all the time at JPL, can you think of something we should put up there? We have racks and racks and racks empty. We will, they even offer, so the iPhone, that one, 6, has got a medal that I developed, well, I should say my team developed. My team out of Caltech developed the material for iPhone 6. It's not gonna bend like your iPhone 5. And this liquid metal that my team developed, he was asked if he'd like to go to the space station to actually run his experiment. So kind of cool that not only they're begging for work, but there's opportunities for astronauts. So that's kind of cool, but I'm just too damn old. Yeah, I am. Yeah. Hey, I'm retired. Well, you know, if you look at that. So I always go to all the gift stores at all the centers, and I found a new hat that actually says NASA alum. And that's so much better than NASA retired. So JPL, NASA alum, WPI alum. Yeah, you never really leave NASA. All right, that's it. Thank you very much.
Thank you so much.